Okay, so, yeah, that's number one. Anything else you guys want to ask about, like number two or five B or five A or eight? Let's do nine. All right, so we're number nine. Um, yeah, so let's talk about nine. So here you have a velocity graph. So this is something I'm definitely going to ask on our test. I like this question, and I do have a bunch of old tests to give you guys. So you guys can start reviewing for our test. Our test is going to be Wednesday next week. Was it Wednesday? We meet Wednesday? Yeah, Wednesday morning. That's correct. Um, so right now the velocity starts at some value. I don't know what that is, but you know what the y value is. But I know it starts there. So it's definitely moving forward. And when you're moving forward, that's when your velocity is positive. So it's definitely positive at t equals zero. So we're definitely going to include zero. And what does it stop being positive? Right, but you're not going to include one because the velocity is zero. Is zero positive or negative number or neither? Neither, right. Correct. And it's positive again from five to seven. And again, you're not going to include the five and seven. Then when are you moving backwards? It's just the other way around, right? From one to five, and that's it. Because from seven to nine, you're at rest, right? You're not going backward nor forward. So no forward nor backward. Now, speeding up and slowing down. You need acceleration and velocity to be the same sign to be speeding up because acceleration is helping you. So when am I speeding up? So the velocity is positive for the first interval from 0 to 1, but the acceleration is negative because you have negative slope. They're the same sign when you get from one. Yeah, the acceleration is negative from 1 to 2. Definitely from 1 to 2. Well, actually, your velocity, they're speeding up. You're not speeding up. You're slowing down from 0 to 1.
Oh, are we talking? Oh, I thought we were talking about when acceleration is negative.
No. We already did that. Actually, no, we've not done that yet. Um, but you're speeding up, definitely from 1 to 2. And I'm not going to include one because you need velocity and acceleration to both be positive, both be negative, and velocity is zero at one. And you're not differential at corners, so I'm not going to include two either.
If this would be on the test, would it just be an open interval?
I think most likely I'll probably just have to avoid ambiguity. I'll
Okay.
just say because I think on the AP exam they do the same.
Okay.
I think they started doing it more recently, so I think I'm okay with that. But I think for part A, like I mean, you should include the zero.
Yeah.
Yeah. Um, and also we're speeding up from 5 to 6. So that's what I'd say for that. For slowing down would be from 0 to 1. I think you can include the zero though. And also slowing down from 3 to 5 because acceleration is positive, the velocity is negative. And again from 6 to 7. Ha ha ha. No, you guys, okay. It's over now. I know. All right. Yep, there we go. So hopefully that makes sense, the way I analyze that graph. And then the acceleration is positive when the slopes are positive, so 3 to 6. Also, the acceleration is negative when the slopes are negative, so 0, 2, 6, 7. And then acceleration is zero when you're flat, 2, 3, and 7, 9. Greatest speed, it's kind of hard to tell, but I think the interval from 2 to 3 and 0 are probably the same values. Remember, speed's absolute value, and you stand still because there's no motion, zero velocity from 7 to 9. I don't know why snow's not included. That should be included. Anyhow, we could probably do open intervals for that.
Would you tell us open intervals?
But for standing still, you're clearly oh, for more than an instant. Okay, because it just stopped. That's stupid. I'm not gonna ask that question. That's dumb. I'm not. I know I'm not asking that question, so don't worry about that. But I could say like when you're at rest, and if I were to ask for an interval, maybe I to avoid ambiguity, I'll say give me an open interval. So fine. And then the last one was 19. Okay, so for 19, you have an equation. There's your equation. Displacement is just a change in position. So we're going from 0 to 5. That's pretty easy. Average velocity is the slope, change in velocity or change in time. The velocity itself is the derivative of a position. That's 2t minus 3, plug in 4. Don't forget your units. Acceleration is straight up just 2. It's a constant. And it's meters per second squared. You change direction when your velocity changes sign. So change sign at t equals 3 halves. That's it. That's when you change direction. And for F, this they want the lowest position, it looks, or the minimum position. What do I want for 19? Yeah, the minimum position. Okay, got it. So really you're just trying to find the smallest value for S, right? So that's gonna be your vertex. And you want to find the X coordinate that provides it, then actually give the position itself, because you want the position itself. So where is a particle when S is a minimum? So it didn't say when, but where is it? So give the actual position. Or I'd probably just say find me the position that's minimum. Um, so these are just application of the derivative are okay. Cool. Okay. I should have assigned number 6, 7 too. Yeah. Okay, let's move on. All right. All right, so we're gonna just jump to the trig. And I'm not gonna do all the trig examples. I'm just gonna do enough so you guys have enough to do your homework. Homework I already put in Schoology. So there is actually a homework assignment that's specific to this stuff here, because you need to do that. And actually the homework, I'll show you where it is. It's gonna be the 3.5 textbook stuff. And it's just gonna be some trig derivatives, some other stuff you're doing. So nothing too crazy. But if you do want to get a head start to preparing for the test, because I understand a lot of tests next week. I looked at the major assignment calendar. Oh boy, you guys, there's a lot of tests going on next week. So you might want to start preparing early. So I'll make sure I'll give you the review guide. The review guide has just 5 old tests, so you can start doing it. It has all the answers as well. And I'll give you guys more details about the test on Monday once I have all finalized. Okay, so let's start with trig derivatives. Here we go. So if you're using an iPad or a tablet, we're on page 41 of the PDF. So derivatives of trig functions. Okay, before we start talking about derivative trig functions, we should do some work with limits. And we actually do need to understand this limit here. Cosine h minus 1 over h, the limit as h approaches 0. Now, if I do go to Desmos and graph that, y equals cosine x minus 1 over x. As x approaches 0, obviously it's undefined at 0, but you can see the approach. As I approach 0 from the left and to the right, my limit's going to be 0 in each case, right? Or if I plug in a value close, like if I do f of x, I do f of like 0.001. Yeah, it's pretty close to 0, right? Or f of like negative 0.001. Yeah, pretty close to 0, right? So that's what it looks like. How do I prove it? So we want to get a little more sophisticated now. You guys are ready? Get a little more sophisticated here. So here's what we're going to do. Actually, won't someone tell me what we should do? Because if I do plug in 0 right now, I have a problem, right? Don't I get 0, 0? That's a problem. So let's find this analytically. And I have an idea of what we should do. Yeah, let's try that. That's usually a safe bet. Yeah, I agree. Even if we don't quite see like 2 or 3 steps in advance what's going to happen, just take a leap of faith, be persistent. It's a good trait to have, see what happens. If I foil the top, what do you when you foil the top? Yep, you have cosine squared h. Don't forget to keep writing the limit notation. Cosine squared h minus 1. Okay, what do you think I'm going to do about that? So do I turn it to sine or negative sine squared?
Negative.
Yes, negative, yeah. Okay. Nothing cancels right away.
But if it's approaching zero, doesn't sine h divided by h become?
Yeah, good. That's good, Charlie. Yeah, good. So let's see that. I like that. So there's some space here. I could rewrite this expression in this manner. Negative sine h over h times sine h and we know sine h over h. Yeah, if you have negative sine h, and of course you have this one over here as well. So this will be -1 times, and I could just substitute to the second expression. Isn't that just 0 over 2? So overall, what do I get? Get 0. That's it. Get 0. Here we good? Okay, cool. So now, with that knowledge, we can hopefully come up with the formal derivations of these derivatives of sine and cosine. So first off, before we do that, let's actually look at graphically what's happening. Because I could just tell you what it is, but you guys are bearing that. You guys are honor students, right? So y equals sine x. Okay. And let's switch this to, if you guys ever want to change the axes, you can always just do that. There we go. So if you think about it, if I were to draw a tangent line over here, it's 0. Slope is 0 here. The tangents are positive here, but negative here. So, and it's cyclical, right? Like we have all these horizontal tangents at every odd multiple of pi over 2. Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, negative 7 pi over 2, and so forth, right? So what trig function would be 0 at these odd multiples of pi over 2? Cosine, yeah. And doesn't cosine start being positive, right? Starts out being positive. And I think Desmos, no, it doesn't do that. Okay. I don't want to figure out how to find, well, hold on. How do you find derivative in Desmos? I'm gonna discover this. So I gotta do. Okay. So dx. Yeah, so we see that the derivative does look like cosine, right? So there we go. So we see that. Now, if I do cosine x, now if you think about cosine, where's your horizontal tangents? And let me turn off the other one.
0 pi.
Yeah, 0, pi, 2 pi, and so forth. So, and it's likewise negative value. So it's every integer multiple of pi. So in this case, that's going to be like a sine graph. But however, the slopes are negative in the first quadrant, right? That's totally negative in that first quadrant. Then it's positive afterwards. So it's almost like sine inverted. So it's negative sine x, yes. Oh, hold on.
Turn on.
There we go. My bad. Yeah, so that's a negative sine x graph. But let's prove it analytically. All right, so do analytically. And once you do analytically, you can use the shortcuts after that. And I do have a reference sheet. Maybe I'll print while you guys are working. So it might be good for you guys to have. So how would I deal with this? You guys remember? Going back to like September or October?
Sin X plus H, plus cos X.
Oh wow, you remember that. Wow. Good. Yeah, you use the sum difference formulas, right? Yeah, plus cos x times sine h minus sine x all over h. Okay. And this is the limit as h approaches 0. Well, let's plug in 0 for h, see what happens. We're not actually not quite there yet. Hold on a sec. I'm gonna break it off. Hold on. Um, yeah, so let's do this. Sine x Okay, does that make sense what I've done so far? Okay with that? Okay. Um, alrighty. Then okay, now I feel good about this. That's you can factor out sine x. So I'm using limit properties, right? Okay, so far so good. You guys see I factor out sine x from the numerator in that first fraction, the second line. We have sine x times cosine h minus sine x all over h. I factor out sine x. Then we verified that cosine h minus 1 over h is what? Well, 0, right. So you have sine x times 0 plus cosine x times 1. And where you stuck with? Cosine x. So hopefully you guys can see, this is the part where I don't want you guys getting lost, but this part right here, I factor out sine x. And I pull it off to the side of the fraction because I don't need it anymore. It was in the numerator. I just could push it off to the side and focus on cosine h minus 1 over h, which I know is 0. We did that earlier, a few minutes ago. So that's why it's cosine x. So analytically, we've now proven. Okay. Why don't you guys try proving the next one? Do you guys remember the sum formula for cosine? Right.
Cos X plus H minus.
Good.
Sin H.
Okay, listen to this guy. That's right. I'll put the formula for you guys. So cosine of a plus b equals cosine a cosine b minus sine a. Okay, go and give that a shot. We're going to do one more derivation after that, and then we'll do some problems.
Huh? Was it you? That's what did you just get?
Okay.
I don't even know what she saw. Well, I think we'll leave. Well, why don't you guys on the same team?
I have not tried to do this, but. Okay, so that.
Yeah, so you got this right.
Right on, Jay.
Yeah.
So that's why it's negative sine x.
I would have stayed. I was. No.
It's always zero. Yeah, we just did that a few minutes ago.
Fraction. That you use.
Double down.
No, because when we did the conjugate, we wound up getting zero.
Oh, yeah.
Okay, so let's keep going, guys. Now, for next one here, because you guys know the shortcut rules or the the quotient rule, I'm going to think it's d dx of sine x or cos x. So if I take that derivative, remember it's the derivative of the top times the bottom minus the reverse
Oh.
over the bottom squared. What's true of sine x?
Cos x.
Right. What's true of sine?
Derivative of sine.
Sorry, cosine.
Negative sine.
So you want up getting cosine squared x and whatever cosine is the same thing as secant, right? So it's secant squared x. Once you get the hang of it, you kind of just know it and you just say it. You don't have to go through this work. But I need to show you what I just want to just tell you, oh, here they are, and just go for it. Like you actually need to prove it. It's good to prove it right first. Granted, I could prove it 3 more times with these other options, but I think you know what to do. Cotangents, what is an identity? Whatever what.
Oh, that's not.
Yeah, cosine over sine. I understood you. I understand Jan. So cosine over sine. But he knows all the answers. Actually, that's a secret, guys. There you go. Secant. 1 over cosine. Cosecant 1 over sine. So you can do quotient rule a few more times. And there's a time I'm not going to do. I'm just going to tell you what the answers are. I'll just give them to you guys. I trust you guys can work these out if you had to.
Look at memorization seconds.
I do actually. Sorry. Well, I'm not going to let you use a reference sheet for the test, but I'll give you one so you can study from it. So you have a one-stop shop just to look at. Essentially, yes. Yes.
Can we get like a 5 minute in the middle of the test? Look at
No.
Stop.
No. Actually, there is a little technique you guys can use. anything that's a co-function has a negative. Cosine is negative sine x. Cotan is negative cosine squared x. Cosec is negative cosine cotan x. Then sine was cosine. Secant tan. And of course, tan was secant. So that helps. But
You can go see. It doubles. It becomes a-
yeah, you have to when you go through the motions, you actually like do like 1 over cosine x and you do quotient rule, you wind up getting that. I'm not gonna do the derivation because I just don't want to spend too much time on it. All right. So let's work this out. Actually, I think you guys can handle this. Why don't you guys try A and B on your own? We'll check in a few minutes.
Let me see. The derivative of sine is just not the derivatives in the root shapes. Right. We can just H plus X. Is that how you're doing that? It's E.
What's up?
So we.
Wait, what? No, guys, you're using shortcuts now.
Oh.
Yeah, guys, we're not doing this limit nonsense anymore. Only when I tell you to.
Sine x times the derivative of cosine x.
Yeah, do the product rule. Here, just for one question.
Times the derivative of cosine x.
Catch up on that now.
That's my concept.
Can't hear. Are the two functions?
Alright, so.
Goes to the derivative of x.
Oh no, we can use the product for the fund.
Plus
Derivative
goes
something.
Is this
derivative of x is one.
Yeah. It's like x to the first power.
Oh, do you get this? Wow. I'm gonna go with this one.
Is that your attempt at the product?
This is my attempt.
So it's like we just.
Oh gosh,
Stuff with no one was bid from.
Hey, they should come out nice and clean. And remember we talked about how can you verify your work using the calculator? So you could do under the graphic calculator, go to y equals, do d dx of the function and put x equals x. So graph the derivative of the original in the TI-4 calculator. Then right below, type in what you got by the derivative by hand, and they should line up. They should match up when you graph it. So you can always verify your work using the graphic calculator. Emma, you have a question? What's up? Oh, hold on. All right. Did I make a mistake? I could have. Hold on. I did draw the top, which is negative sine x times 1 minus sine x. Never mind. Okay. I think I got it right. I think I am right. Yeah, I'm right. You know what? Let's find out.
Wait.
For x equals c. So I'm gonna do this. So I'm gonna just separate that into two. So we divide it by minus. Plus is the derivative of plus what is sine x? So it's the minus.
So the derivative of this.
Yeah, they're the same.
Oh, I can. Yeah, the derivative of this, take the derivative of the x.
Yeah, they're the same.
Which we use the product of the x cosine.
All right.
That's significantly one.
Okay,
Plus, the derivative
Are we good?
of cos x, which is then how?
I'll slow down. I'll take a little break.
One times sin x
Oh,
in the first one.
you multiply.
What was that?
No, you don't
Where the
multiply.
one times sin x in the first one?
Oh, deriv x is 1
Yeah.
times sin x. It's product rule. Remember, the product rules you do the derivative the first time the second plus vice versa. So it's f prime g plus f g prime.
The derivative.
The product rule.
Oh.
I'm doing product rule, right?
Yes. Okay.
So you can see how everything's building upon itself, right? We're doing stuff in 2 sections ago. We're using all the differentiation rules, right?
Wait, the whole graph? It's.
The normal graph is what? Sorry. Correct. Yes. Yes. Perpendicular to a tangent line.
How do I make? What's?
We'll get there. You're ahead of us, Lucas. Just give me a sec. Really quickly, which I think will help you guys tremendously. Probably should be doing this over the weekend and do some practice so you are get more familiarity with the rules. So I made this many years ago. I think in 2012 I made this. So you should know the limit definition of the derivative. You should know all these other rules here. Definitely should know power product quotient rule. We've not done chain rule. I won't cross it off because you will need it. We're going to do it in March. We're not going to do implicit differentiation. That's next year you do that. We're not going to do derivative inverses, but we are doing linear motion, velocity derivative position, acceleration derivative velocity, speed is absolute velocity. All the trig stuff's right here. We're not doing inverse trig. You'll do that next year. We are going to do exponential log functions. So I'll print these so you guys have access to this, but we're not going to be doing the inverse stuff, just so you know. That's and of course I do low d high minus high d low by low squared, and away we go. So I put the rhyme there as well. So anyhow, I'll actually, let me print it right now. Yeah, because you guys will freak out, right? All right. See here. I'll print one, then I'll cross it off and print again.
Middle.
No.
All right, let's keep going, guys. All right. Okay, next up, example 2. So y prime, guys, quiet, is negative cosecant x. Okay, that's why I need my other hand here. Negative cosecant x times cotangent x. And you're asked to write the equation of the normal line. Okay. So when x equals pi over 4, y prime is going to equal negative cosecant of pi over 4. And do you need to know how to evaluate trig stuff using the unit circle? Yes, you do. Cosecant pi over 4. You guys remember what that is?
For 2. I first.
Pi over 4.
2 over root 2.
So it's root 2. Yep, it's root 2. Yep.
Oh, that's what's. What would you do?
Okay, so here's what I did. I found my derivative because I showed you the rules for it. You could do the formal proof if you want. I don't care. But it's negative cosecant x cotan x. Plug in pi over 4. Cosecant pi over 4 is 1 over root 2 over 2. You flip it, becomes 2 over root 2. Rationalize, it should become root 2.
Why is it not cotangent? So shouldn't it be negative cosecant squared?
Oh, crap. I did cosecant. My apologies.
Yeah.
My apologies, guys. My apologies. What did I do it wrong in the? I did it wrong on the previous page, right? What did I tell you guys on the previous page? I told you guys
Yeah.
Negative cosecant squared. My apologies. I'm tired. Okay. Sorry about that. My apologies. Y prime was wrong. It was supposed to be this. Okay. Thank you, Kaden, for catching on Sydney as well. My apologies. Now, x equals pi over 4. So make a correction. So y prime is going to be negative cosecant of pi over 4. And what's cosecant of pi over 4? That's root 2. So it comes negative 2. Okay. And y will be cotangent of pi over 4, which of course is 1. So what would the perpendicular slope be? 1/2, right? Yeah, so again, y prime is negative cosecant squared x. Cosecant pi over 4 is root 2. So it's root 2. Square it becomes 2, but it's a negative, so it's negative 2. But since you're doing perpendicular slope, because it's normal line you gotta do negative reciprocal negative 2, just 1/2. That's the slope of your normal line. And of course, at pi over 4, y is 1, because you put it back in the original equation. And you should get that formula. Does that make sense?
I get the slope.
Was that?
How'd you get the slope?
Well, my derivative is negative 2. I want normal.
Yeah.
Right? I want normal. Normal is perpendicular. Okay, why don't you guys try example 3 and 4? And we're going to stop there. I don't want to do simple harmonic motion. I don't care for that. That's a physics thing. I don't care for that. So we're going to try examples 3 and 4. We'll check in a few minutes and we're all done.
No, U prime. So prime represents the yeah. I think that get that. What? I ain't got that. I had this.
Can you show me B again?
Was that?
Can you show me B again?
Oh, I'll show it to you. Give me a sec.
Yeah, I'm not good my answer. I answered by as a couple.
What did you like do in the middle?
In the middle, so I put everything, I put in the full, that's it. Okay. So, and then I got sine x, 1 minus sine x, times x and negative cosine x. So, and then I got this. So you guys, this is cosine x squared. And then
Okay, yeah, try. Let's see.
You just run me through this. Do I wanna?
Yes,
Let's
did
see
it,
if
right?
you can get with the word.
No, you just using approaching roll.
No.
I mean, sure, you can do that.
That's why I can
Yeah,
ice this, so I can get rid of
it
one
anyway. So do that's gonna be negative cosine.
Yeah.
So it's cosine x times, yeah, you do the top, which is gonna be negative sine x. Wait, no, you don't do that. The quotient rule is that cosine x derivative.
So this stays as 1 minus sine x.
Correct, yeah.
Oh, yeah. I see.
Minus the reverse. Cosine x times 1 minus sine x.
Yeah.
Oh, no, yeah,
probably.
Which the answer is.
See?
Let's go back to secant.
I got secant squared x, actually. I think.
You can only factor out secant. You can factor out 2.
But tan squared x plus 1 equals secant squared x, right?
Oh, it's
Plus one? Yeah.
Yeah.
Yeah. U squared. Also one. So it's negative.
Oh, wait, no, hold on. Never mind. I'm tripping.
No, where does the one come from?
I don't think you can do anything about that.
You didn't bend to the sound.
Yeah, no, you just leave it alone. Yeah. Yeah, guys, just leave it like that yeah, just leave it alone. You can't simplify it. Yeah, you can factor out secant x, and that does nothing for you because tan squared x plus secant squared x is not anything. So leave it alone. And lastly, for this one,
Minus sine x, that would be your g of x.
Yeah, and that turns into.
No, this would turn into one, one minus two sine x plus sine squared.
Oh, yeah, you're right. Yeah, because I was thinking it was conjugate. Well, I might just skip the L.
What stands for being negative sine x plus one
Divided by 1 - 1 squared.
Oh, I have something else. I thought I was.
I have a negative sine x over.
No, my movement is a negative sine x plus. Negative sine x plus.
which one? I don't know. Well,
Yeah, because.
secant pi over 3. Well, I would ask for exact answers anyway. What's secant pi over 3? So cosine pi over 3 is 1/2. So secant's 2. So you end up getting 4 pi over 3. And tangent pi over 3 is going to be root 3.
One.
Gosh, that's really nasty. What were we thinking of this question here? What? Oh, geez. You know what? Let's forget about example 4. I'm not going to ask that. Just forget about it. It's okay. Just forget about example 4. It's all good. You guys get the idea. We accomplished what we needed to. Yeah. So what I produced, just so you know, I'm just gonna briefly talk about the test and then let you guys, and we don't have too much time, class is almost over, but
Review that.
yeah, I'm gonna hand it a moment. Hold on.
Yeah, I don't think we got secant x times tan x plus something.
This is not even right down.
I don't know.
I'm right.
Wait, what was your?
I erased it.
Not very confident in that answer.
What?
1B.
1B, we all got different answers, so we asked chat, and gave us a double completion.
Hold on. Wait. No, I did 1B with you.
We did chat, we did our.
Yeah, like we,
Go back.
I erased all my work.
No, I got one of 1 minus x.
Oh.
I think 1 minus x is canceled.
Yeah, I got the one on the.
Yeah, I would expand the logic.
Wait, Teddy, what did chat say?
Yeah,
Or something.
oh, so like,
Yes, it's just take the derivative.
okay, let's try that.
Okay. I'm gonna hand this out in a moment, but just so you know, these are some old tests from AP Calculus. Like this is like 2017. We used to teach this in the fall of AP Calculus AB. So like, yeah, I will ask you to find the slope of the curve, but you have to use a limit definition. I'll ask you like find a normal tangent line. I'll ask you to be able to recognize the formal definitions of the derivative, things about continuity and differentiability, finding derivatives, second derivatives, graphing stuff, more derivative stuff. The whole idea of differentiability, cusp, vertical tangents, again, more graphing stuff. I love these kind of questions where you have to force the issue of continuity and differentiability, solving for constants, some things with piecewise functions, and my favorite, these kind of questions where you have to like
Oh, yeah, don't worry about it.
use all the conditions and make a graph from it. And they're all the answers are included. And I have 4 more tests as well. So you have plenty of practice tests. So plenty of practice here. So let me hand that to you guys. I'm gonna make that right now.
The ones we're getting touched.
Only you got it.
So we're gonna. Yeah. The ones we get from the cumulative focus. All right, so they look like. It's not.
Not have that flavor straight out.
Certainly.
Oh. Rubber under 50.
Why?
There's a little bit of weight behind it.
There we go. That's what they got. I don't think Chad, I don't think Chad.
This guy has weight to it. Okay, let it pass. He's got.
You got plenty of practice. You got a week of practice.
We have ample.
Okay, we'll go get those cheat sheets. Hold on. I'll look at my